Hello, ladies and gentlemen. I want to touch on what we were discussing today in class. We want to prove the cosine law using vectors. Okay, so we did this in class and we got a very wrong result. I wasn't able to figure out exactly why it was wrong during class, but I do now. So I'd like to go over this and show you what was wrong, and then we'll show you how to do it right. So let's give ourselves any old triangle. Okay, and what we want to show is we want to show that a squared equals b squared plus c squared minus 2bc cosine theta. Now what's going to be important here is this theta is supposed to be angle A in this case. Okay, so it's opposite the side that I'm squaring. But when we work with vectors, we have to remember that this theta is going to be the angle between two vectors. Now let's remember that it needs to be the angle between two vectors, and the angle between two vectors is always from tail to tail. And that's where we ran into a problem in class today, and I'll show you exactly where. So we started off by saying we're going to go with BC, and we're going to say that BC is composed of, so here's BC, okay, it's going that way, and BC is composed of BA plus AC. So we said if we take this vector, and if we take this vector, then we get BC, and that makes perfect sense. So we get BA plus AC, and that is simply vector addition. Okay, it's an O. All right, so that's very good. So then what we did was we dotted both sides. Lauren, you had a good idea. It's kind of like squaring both sides. Not a bad idea, not a bad way to think about it. And so we dotted both sides by itself. So what that gave us was the magnitude of BC squared. And so using the distributive property, we're going to take this whole thing and it's going to be distributed over like that. Okay, and then we're going to take this guy and distribute him in here. I'm going quickly because we've been through this already today, at least twice. Okay. Now this is the commutative property. AC.BA is equal to BA.AC. So this gave us two of these. And this gave us BC was A squared, BA was C squared. This was giving us AC squared was B squared plus 2 magnitude of AC, magnitude of BA, cosine the angle between AC and BA. And that's where we ran into problems, because the angle between AC and AC this way, the angle between AC and BA is not here. It's not A. It's not vertex A. Okay, take a look up here. For it to be the angle between them, they have to be put tail to tail. So this is in fact the angle that we have up there. This is not A, so therefore this whole thing cannot be a proof to the cosine law. And that's why this doesn't make any sense if this is A. This is not vertex A. Absolutely not vertex A. That's what we were doing wrong in class. Okay, I'll stop here and I'll do a new video on how we should do this.